everyone, and welcome to another deep dive. Today we're going deep into the world of AI, specifically those large language models, LLMs as they're often called, that are powering all these incredible new chatbots. You know, the ones where you type in a question and get back an answer that sounds eerily like a human wrote it.
It is pretty amazing how far they've come, right?
Absolutely. But have you ever stopped to think about how these LLMs actually understand what we're asking? Like, how do they make sense of the words we use, especially the order of those words?
It's a really good question. And honestly, one of the biggest challenges facing AI developers right now, it seems so basic to us, understanding word order, but for machines, it's a huge hurdle.
Right. It's like to us, word order is just intuitive, but for AI, it's something they have to learn from scratch.
Exactly. Think about it this way. It's the difference between knowing what words are in a sentence and actually understanding the relationship between those words, how they work together to create meaning.
And that relationship, the order, it often completely changes the meaning, doesn't it?
Exactly. And that's where some fascinating new research from Meta comes in. They've developed a new method for teaching LLMs about the importance of word order and position, and they call it contextual position encoding, COPE for short.
COPE. Okay, I like it. But before we unpack COPE itself, can you give us a real-world example of how this whole word order thing can trip up even the smartest AIs out there?
Absolutely. So LLMs use something called attention to focus on specific parts of the text they're analyzing. It's kind of like shining a spotlight on the most important words in a sentence.
Okay, so they're focusing on the right words, but still having trouble with the order.
Exactly. Simple attention can tell you what words are important, but not necessarily the order or how important they are based on that order. It's like the AI is seeing all the pieces of a puzzle, but can't quite figure out how they fit together.
Okay, so it's like they know the words, but not the song.
Perfect analogy.
Ah.
And this isn't just a theoretical problem either. Even really powerful LLMs like, the big names GPT-4, Llama 2, they can struggle with this too.
No way. Those are like the rock stars of the AI world. What happened?
Well, the Meta researchers gave them a passage from, of all things, Alice in Wonderland, and it actually stumped them.
You're kidding. What was the passage?
Okay, so it was, and I quote, Alice was beginning to get very tired of sitting by her sister on the bank and of having nothing to do. Once or twice she had peeped into the book her sister was reading, but it had no pictures or conversations in it. And what is the use of a book, thought Alice, without pictures or conversations? So she was considering in her own mind, as well as she could, for the hot day made her feel very sleepy and stupid, whether the pleasure of making a daisy chain would be worth the trouble of getting up and picking the daisies when suddenly a white rabbit with pink eyes ran close by her. And they asked the LLMs a seemingly simple question. How many times does the word Alice appear in the last sentence of that passage?
Okay, let me see. Just in that last sentence.
Sounds easy enough, right?
It does. It's just basic counting.
Well, both GPT-4 and Llama 2 got it wrong. They got tripped up by all those earlier mentions of Alice in the passage. It's like they couldn't focus on just the last sentence, even though that's all that mattered for answering the question.
Wow, that is kind of mind-blowing when you think about it. It really shows you how important understanding position is. Even for something as basic as counting, our brains just seem to do it automatically.
It's one of those things we take for granted. Our brains are amazing at filtering out irrelevant information and focusing on what matters. And that's exactly what COPE is trying to replicate in AI.
So how does COPE actually work? Is it some super complicated algorithm that only like a team of PhDs could understand?
Well, the math behind it is definitely complex, but the core idea is actually quite elegant. Imagine a detective trying to figure out the order of events at a crime scene. They don't just look at the timestamps on security footage, do they?
No, of course not. They look for clues, connections between events, trying to understand the bigger picture.
Exactly. They're looking for context, cause, and effect, all those subtle details that help them put the pieces together. And that's kind of what COPE does with language. Instead of assigning each word a fixed position in a sentence, like it's stuck in a numbered queue, it uses something called gates.
Gates. Okay, like what do they do?
These gates, they basically determine which parts of the text are actually relevant for figuring out the position of a particular word. It's like having a filter that sifts through all the information and highlights what's important for understanding the order of things.
Okay, so it's not just about where a word is in a line of text. It's about its importance in the overall context.
You got it. And here's where it gets really interesting. This whole process, the gates and the filtering, it happens for every single word in a sentence. So the way position is measured, it's not fixed. It actually changes depending on the word and the context it's in.
So instead of a rigid ruler, it's more like a flexible tape measure that adapts to the task at hand.
That's a great way to put it. COPE is dynamic, context-dependent, and that makes it far more powerful than any of the old methods for teaching AI about word order.
This is starting to make a lot of sense now, but how do we know COPE actually works in the real world? Did they, like, set it loose on the entire Library of Congress and hope for the best?
Well, not quite. They designed some very clever experiments to see how COPE would handle a variety of language-based challenges. And honestly, you won't believe the results.
Okay, you said I wouldn't believe the results, so spill it. How did COPE do?
Well, they put COPE through its paces, with not one, not two, but three different tasks, each designed to really test a different aspect of how it understands position and order within language.
Okay, so like an AI obstacle course, but for word order. I'm into it. What was challenge number one?
Challenge number one was the flip-flop task. Picture this. You've got a ton of instructions, like a ridiculously long to-do list, and hidden somewhere in that massive list is one really important command, the rest. Just filler, distractions, noise. And the AI has to find that one crucial command.
Okay, it's like finding a needle in a haystack, but the haystack is made of words.
Exactly. The flip-flop task, it's all about testing whether an AI can pick out crucial information based on position, even when it's surrounded by a bunch of irrelevant stuff.
Sounds tricky. So did COPE pass the test?
Oh, it passed with flying colors.
Yeah.
But that was just the first hurdle. Task number two, this one's called selective copy. And it's kind of like, when you have to copy a really long document, but you only need certain parts of it.
Yeah, the worst. Right. You have to be so careful not to miss anything.
Exactly.
Yeah.
And that laser focus, that's exactly what they were testing. They wanted to see if these AIs could understand the positions of words relative to each other, even when there are gaps or inconsistencies in the text. Can they find the important bits while ignoring the fluff?
Okay, so it's not just about recognizing the important words, it's about understanding the relationship between those words, even when they're not right next to each other.
You've got it. And then for the grand finale, they put COPE through the counting task.
Okay, let me guess. This one involves dot counting.
What gave it away?
Just a hunch.
But here's the thing. Instead of counting like physical objects, it's about counting actions or instructions within a set of commands. For example, if I told you to go left, right, left, straight, right, how many times did I say left?
Twice. So in this task, the AI has to keep track of what it's already heard and not get confused by the other words in the sequence.
You got it. It needs to understand both the order and the specific things it needs to pay attention to. So after all those challenges, the flip-flop, the selective copy, and the counting task, what's your guess? How do you think COPE stacked up against the competition?
Well, based on your, shall we say, enthusiastic descriptions, I'm thinking COPE totally crushed it.
You would be right. COPE consistently outperformed the other methods. And it wasn't just a small difference either. The more challenging they made the tasks, the more COPE really pulled ahead. Longer sequences, more complex instructions. COPE handled it all without breaking a sweat.
So this is a really big deal then, right? We're not just talking about a minor improvement. This is a significant step forward in how AI understands language.
Exactly. What's really exciting is that COPE's success wasn't limited to one specific task. It consistently performed better across the board. This suggests that we're onto something truly groundbreaking in terms of how AI processes and understands the nuances of human language.
That's incredible. But I know our listeners are probably wondering, okay, this is all very impressive, but what does it actually mean for me? What's the big takeaway?
The big takeaway here is that we're on the cusp of a major AI revolution. Thanks to breakthroughs like COPE, we're talking about AI systems that can not only process language, but actually understand it in a way that's much closer to how we humans do it.
So no more clunky chatbots that just spit back canned responses. We're talking about AIs that actually get the nuances, the intent, maybe even the emotion behind what we're saying.
Exactly. Imagine talking to your virtual assistant, and it not only understands what you're asking, but also the context, your preferences, your goals. It could revolutionize everything from customer service to education to entertainment.
Okay, so we've gone from AI that can write a decent email to AI that could write the next great novel.
Well, let's not get ahead of ourselves, but it does open up some really exciting possibilities. And the best part is that this isn't just some far-off fantasy. This research is coming from Meta, a company that's deeply integrated into the tech we use every single day. So these breakthroughs could start showing up in our lives a lot sooner than we might think.
That's what I love about these deep dives. We're not just talking about pie in the sky ideas here, it's about real research with the potential to impact our lives in the very near future. But as always, we like to leave our listeners with something to ponder. So, expert, what's that final thought provoking nugget you want to leave us with today?
Here's something to chew on. If we can teach AI to understand the order of words, what happens when it starts to understand the order of ideas? Could an AI follow the flow of a complex debate? Could it understand historical narratives with all their twists and turns? Could AI learn to appreciate the subtle art of a well-crafted joke? This is just the beginning of what copy and similar advancements might enable, and it's an incredibly exciting time to be paying attention to this field.
It really is. It sounds like we're on the verge of a whole new era of AI, one where machines don't just process information, but actually understand it in a way that's closer to human cognition than ever before. I, for one, am excited to see where this all leads. A huge thank you to our amazing expert for breaking down this complex topic in such a clear and engaging way. And thank you, our listeners, for joining us on this incredible deep dive into the fascinating world of AI. Until next time, keep those curiosity gears turning.